Good evening. Today, we are presenting AutoGrow, an IoT-based smart system that automatically manages plant growth from seed to harvest.
For overview and motivation, AutoGrow grows beyond passive monitoring. It actively controls the growing environment throughout the plant's entire life cycle. Our three objectives were precision environment control, autonomous resource optimization, and the data-driven insight like a plant health score and harvest ETA.
And here is our overall architecture. The system flows like this. The kit bright sensor collect data and publishes via MQTT right to a Node-RED broker. We store it in our remote MySQL database. Then a fast API backend process that data, make decision and send command back to the actuators, the pumps and the RGB grow light. External weather APIs provide outdoor context and everything is displayed on the Next.js web dashboard.
For data source, our primary data come from 4 sensors on a kit by 32, a soil moisture sensor, 2 temperature and humidity sensor, a light sensor, and a vibration sensor for pump health monitoring. Data is published through MQTT every 10 minutes.
And here is our secondary sources. The first one is Open Meteo API that we collect outdoor weather context. And the next one is Sunrise Sunsets API. And the last one is Local Plant Target Database. And here is the database schema, like you can see our table on PHP for primary sources, right? And here's for secondary data. And here is our database schema used for data integration.
For the data sharing API, the Fast API backend exports 3 groups of endpoints: plant lifecycle management, handle starting, monitoring, and harvesting session. Sensor telemetry provide raw data, stream and hardware status, and our intelligent endpoint harvest, health, contact weather, combine sensor data with internal APIs to generate predictive insight.
And here is our tech stack. Let's move on to the data visualization part. For the first one, this is a real-time series live chart monitoring temperature, light intensity, soil moisture, and humidity levels. It provides a comprehensive overview of the glasshouse environmental trends over specific periods of time. For this one, it is a scatter plot examining the relationship between soil moisture and outdoor humidity levels to determine how external climate factors influence the soil's evaporation rate over time.
The scatter plot analyzing the correlation between indoor and outdoor temperature. Data point above the dashed line indicate instance where the glasshouse was warmer than the outside.
And here is a daily comparison bar chart showing average of internal glasshouse data versus outdoor weather data. This visualizes how effectively the system maintains stable conditions relative to external environment changes. And here is the graph that displays the direct correlation between soil dryness and pump activity. And here is the demonstration of our key features, which are, the first one is intelligent actuator control layer. The concept is that we want a dynamic spectrum adjustment based on live growth stage. So how we do this is that the backend trigger MQTT commands to switch between blue and red and white. And the next one is automated irrigation system. The concept is that we want a closed loop watering based on a real-time soil moisture level. So the action is that if soil percentage fall below the defined threshold, the backend logic trigger the water pump via MQTT. And here is the image from our hardware that we have actually set it up. So we have like install all the sensors and the kit by board on this box, and then we plant the real plant here. And as you can see that like we actually have harvested these plants and actually made it into a real food. It tastes good though. And here is the dashboard of our website. As you can see that user can see multiple data about the plant that they have grown. And here is when the user is going to harvest the plant. It will reset everything, right? As you can see. And here is when we are going to start a new plant. And here's the team behind the project. So thank you for having us today. See you again next time.